Hi there, this is Dirumunduluru and welcome back. Now that we have a basic understanding of what compilation is, let's look at what platform dependency is. We'll also do a short demo of platform dependency. Let's first consider a Windows machine and let's also assume we have written a C program called hello. To compile this program, we can use a compiler called GCC, and this would be the command gcc space -o space hello.c, where hello.c is the file containing the C program, while -o is an option that tells compiler to name the output file as hello, which will have a .exe extension on Windows. So on compiling hello.c, we get an executable file called hello.exe, which includes the machine code. Here compilation step is also doing something called linking. Generally, any software comprises of many source code files, and each source code file is compiled into a separate file called the object file, which has an extension .o or .obj. For example, in this case, it could be hello.o. And these object files are then grouped or linked to form a final executable file. This linking in many cases is done by the compiler itself. However, it can also be done manually by programmers themselves using another program called a linker. In this example, compiler does the linking and is generating an executable called hello.exe, which is finally executed by just typing in hello at the command line. Similarly, we can also compile the same hello.c program on a Linux machine using the same command as on Windows, and this would also produce an executable, but in Linux, the executable will be named as hello.out. So the extension is out here rather than exe, which can then be executed by typing /hello. So what we have here is both the executables being successfully executed on the machines on which those executables are generated. But this wouldn't be possible. That is, hello executable generated on Windows machine cannot be executed on Linux. And that is an example of platform dependency. That is, hello.exe can be run only on Windows operating system. To run it on Linux, we would have to recompile hello.c program on Linux. Similarly, the hello executable generated on Linux cannot be executed on a Windows machine. You would have to recompile on Windows. So the generated executable is specific to the operating system. So platform dependency has to do with operating system, and one main reason is due to the format of the executable file generated. Okay, it is due to the file format. Windows uses a format called PE, which stands for portable executable, while Linux uses a format called ELF, which stands for executable and linkable format. In case you are interested about these formats, you can read more about them on Google. Just search for portable executable or ELF and you can read more about them. Another reason for dependency on operating system is when the program makes system calls. System calls are useful for performing operations like file opening, directory creation, or even printing to console or the terminal. System calls are routed to the operating system's kernel. Platform dependency can also be due to hardware. For instance, machine code generated for a program on an x86 processor would be different from the machine code generated for the same program on an ARM processor. So the machine on which an executable is executed should be similar to the machine on which it has been generated. Otherwise, it has to be recompiled using an appropriate compiler. So both operating system as well as hardware play a part in platform dependency. Next, we will see how an interpreter can help resolve the platform dependency issue. But before doing that, let's just do a quick demo of platform dependency. Okay, this is my Windows machine, and here we have a program named as hello.c, just as in the slides, and all it does is prints this message called hello world onto the screen, onto the console, That's all it does. So let's just go ahead and compile this particular C program. This is my command prompt. So let me just say GCC, the GCC compiler -o, and the output file would be hello. So it would generate hello.exe space. The input file is the C program hello.c. Okay, so that would have generated hello.exe. Okay, so now let me just run this. Hello. And as you can see, it prints the text hello world. Now let me copy this C program onto a Linux machine and then we will recompile it there. So I have a Linux box too. So let me just, so this here is my Windows and this is my Linux. So here is the hello.c program. So let me just copy it here. Okay, it's copied. Let me open my Linux terminal and compile it and run it too. So I have the command here. I think the font is not as big as in the other window. So it's GCC space -o hello and hello.c, the same command. So let me compile this. Okay, it's compiled. So to run it, all I will do is /hello, and it would have created hello.out here. Okay, so it prints the text hello world. Okay, so that is good. Now let me copy the exe file that got generated on Windows onto the Linux machine and let's see if we can run it. So let me copy this here. This is the hello.exe. Copy it here. So here, to run it, let me say sudo space /hello.exe and it says command not found. Okay, so it is not possible to run the .exe generated on Windows on a Linux machine. So one thing that can be done here is either we have to recompile, that's what we did earlier, or we can use a software called Wine, okay, which will allow us to run Windows programs on Linux. So let me just say, so here we are on the Linux machine. Now as you can see, it is helping us to do this. Okay, so that's just for your information that we can use this software called Wine. Okay, so that clearly says that C is not platform independent, so it is platform dependent. Now let me copy the executable generated on Linux onto Windows and let's just test the same thing. So here is the executable on Linux. So let me copy it here. Okay, so let me open my, and let me just type in hello.out and that's it. So we are unable to run the executable generated on Linux on the Windows machine. So that is platform dependency, and next we will see how interpreter helps resolve this. And Java, as we said earlier, is platform independent. So later we will have a Java program and we will also test platform independence. That's it. Thank you and see you in the next lecture.